Welcome back to AP Statistics. This is Dr. Kling, still not affiliated with the College Board. And last time we talked some about hypothesis tests. I gave what I think of as a gentle introduction to hypothesis tests. And now I'm going to introduce an awful lot of jargon that pertains to hypothesis tests. Remember, statistically, all we're thinking about when we do a hypothesis test is if we got an X bar, let's say here, how likely is it that the true mu is, let's say, somewhere over here? And we calculated this probability using the sort of percentile type calculations, and we called this probability a p-value. And we said that's the probability of observing X bar if the true population mu were some target value. And we're going to call that target value mu naught. That is a subscript. An O means for naught, or a 0 means for naught. And I'm going to introduce the first new piece of jargon. It's called the null hypothesis. So this is the British call this a naught, meaning a 0, and it's called null hypothesis. Of course, in the public schools now, and so now I call it. This is just called the HO, but if you're properly British, you call it H naught, and I might do that every now and then. And it is that mu is equal to some specific value. Last time we had a problem where I think we said the null hypothesis was that mu is equal to 3,000 or something like that. So that was our mu naught. So the null hypothesis is always an equality. So it could be, we could have had the null hypothesis is that the number of calories you eat per day is 2950. That's always something equal. If we were talking about a null hypothesis about a sample proportion, we would be talking about p. Now p is not the p-value, so I'm going to put sample proportion. And suppose our null hypothesis is that the sample proportion is that 45% of voters favor something, or something like that. That would be another example of a null hypothesis. And then the alternative hypothesis is another term which we call HA, so people call it the ho and the ha. HA is the alternative hypothesis, and that's always an inequality. So the alternative might be people eat less than 3,000 calories, or that more than 45% of people favor a certain thing. So that's an alternative hypothesis. And so now we'll define the p-value. Now people want to say, they'll want to say that it's the probability that the null hypothesis is true. But that is wrong, at least in classical statistics. In classical statistics, you can't make a probability statement. I'm saying this again about a parameter. So we have to say that our our statistic, our sample statistic, X bar, is unlikely to be observed. Observed if H naught is true. So the right way to define a p-value is the probability of observing sample results at least as far from mu naught as our results indicate, or as our results were turned out. So it's the probability of observing our sample results, our X bar, if the mu naught were true, or if the, well, I'll do it this way, if the null hypothesis, H naught, were true. Okay, so that's that, and now we're going to introduce some terms. We have some decisions to make. We can reject the null hypothesis, which is something we ought to do if our X bar, if our p-value is low, meaning that X bar is far from the null hypothesis value. And when we reject H naught, we can also, that's the same thing as accepting HA. So that's one choice. The second choice is to fail to reject the null hypothesis. But we do not say we accept HO. Let me give an analogy there. There was a famous trial of O.J. Simpson for murder, in which he was acquitted. So if the null hypothesis is that he's innocent, that is, you're innocent until proven guilty, and he was acquitted, but that doesn't mean we have to accept the idea that he's innocent. It just means we didn't find enough evidence beyond a reasonable doubt to convict him. And we talk about that in terms of, we call type 1 and type 2 error. So let me do it in terms of a jury trial first. So truly innocent and truly guilty. And we don't know whether someone's truly innocent or truly guilty. We end up voting to convict or acquit. Okay, and if we convict a guilty person, presumably that was a good decision. If we acquit an innocent person, that's a good decision. If we convict an innocent person, send an innocent man to jail, that's something we should not do. We should not convict somebody unless you're sort of guilty beyond reasonable doubt. So we'll call this a type 1 error. Letting a guilty person go free is a type 2 error, a less serious error according to our judicial system. Actually, I once served on a jury trial, on a trial where I know we committed a type 2 error, and I actually voted for the people doing it. I would explain that, but that is a bit of a digression. So, convicting an innocent person, sending an innocent person to jail is a type 1 error, very serious. You'd rather not let a guilty person go free, but you'd prefer to err on this side rather than on that side. Okay, so in statistics, we could have the null hypothesis be true. We don't know whether it's really true or false. It's totally unknown. All this is unknown, whether it's true or false, just as we don't really know whether O.J. was guilty or innocent. And we can reject H0 or fail to reject. Okay, and if we reject the null hypothesis, and when we reject it, we accept HA. When we reject the null hypothesis and it's false, that was a good decision. When we fail to reject it when it's true, it's a good decision. When we reject it when it's true, we say that's a terrible mistake. And when we fail to reject it when it's false, we say it's a less terrible mistake. And so that's where the type 1 and type 2 errors come from. So now I've defined more jargon. And so now let me find, so how are we going to make sure that we're less likely to commit a type 1 error than type 2 error? Well, the traditional way is to have the investigator pick a probability of type 1 error that is small. And we call that probability alpha. And a typical value for alpha is 0.05. Boy, we're just throwing that jargon right at you. Alpha, probability of a type 1 error, 0.05. So what that means in practice is that we look for a p-value below alpha. It will be low enough to reject the null hypothesis. That is, the probability of observing our sample results is less than 0.05 under the null hypothesis. So if the null hypothesis were true, there's less than a 5% chance that we would have observed our sample results, and so we reject the null hypothesis. And when we get a p-value above alpha, again, alpha is our choice. 0.05 is the most common. When in doubt, choose 0.05. When it's above it, then we fail to reject the null hypothesis. So that's, I think, a pretty complete tour of the jargon of hypothesis tests. Well, there's one more thing. Remember when I said that the alternative is an inequality? So usually the inequality will be either mu is less than mu naught or mu is greater than mu naught. But we also could have mu not equal to mu naught. That is, we don't care whether it's less than or greater than. And that is called a two-sided alternative hypothesis. Alternative. So that's our last piece of jargon, two-sided alternative. And next time we'll try to do some examples.